Welcome guys to MathTech once again, and this is another amazing time with the math series, and this is our topic 3. And today we'll be focusing on factors and prime numbers. So guys, now we'll be taking these definitions. Now talking about factors, prime numbers, prime factorization. Don't forget our the topic is factors and prime numbers. So now talking about factors, any pair of whole numbers are called factors of their products. Now let me give you an example of this. Now if we are asked to say, okay, let me use this. 6 is equal to 2 times 3. But 2 times 3 is not the only 2 and 3. The value 2 and 3, they are not the only factors of 6. Factors of 6 are 1, 2, 3, and 6. Also, let's take another example. Let's say 18. 18 is equal to what? 2 times 9. But 2 and 9 are not the only factors of 18. We still have other factors of 18. Now, talking about 18, 18 is equal to 1 times 18. 18 is equal to 2 times 9. 18 is equal to 3 times 6. So, factors of 18 are 1, 2, 3, 6, 9, and 18. Hope that's clear. This is a very simple topic. Very friendly one. So we all should swing together. Have fun. So next we'll talk about the prime numbers. Now, while I was growing in my secondary school, I learned prime numbers as the definition of prime numbers: any number that can divide itself and 1. But let's take a look at this definition. Still the same definition, but in a different approach. Now, if a whole number has only 2 factors, which are itself and the number 1, that number is being called a prime number. It sounds interesting. If a whole number has only 2 factors, which are itself and 1, so now we just learned about factors. Now let's pick the first 5 prime numbers, and let me give you a proof of why they are prime numbers. The first 5 prime numbers, we have 2, 3, 5, 7, and 11. These are the first 5 prime numbers. Now, go back to this definition. An interesting definition. If a whole number has only 2 factors, which are itself and the number 1, it means that whole number is a prime number. Now let's take 2. Let's start with 2. Now list the factors of 2. The factors of 2 are just 1 and 2. So it means 2 is a prime number. Now let's take a look at 3. The factors of 3 are 1 and 3. It means 3 is a prime number. Take a look at 5. Factors of 5 are 1 and 5. It means 5 is a prime number. But 4 is not a prime number. 6 is not a prime number. Now take a look at 4, the number 4. Now 4 is 1 times 4, 2 times 2. So 4 has more than 2 factors. Same with 6. 6 has more than 2 factors. But 7 has just 2 factors, which is 1 and itself. Same with 11 here. 2 factors, 1 and itself. Now the question goes down here. Is the number 1 a prime number? And the answer is no. 1 is not a prime number. From this definition, it says if a whole number has 2 factors, what are the factors of 1? We just have 1 as the only factor of 1. So 1 is not a prime number. So now we can list other prime numbers. You can also use your conceptual definition, which is a number that can divide itself and what? 1. So you can list them. Part of those numbers are 13. After 13, we have next 17. We have 19. We have 23. 24, 25, 26, 27, 28, 29. We have 31. And it goes down. So by yourself, sit down and write the first 100 prime numbers. Snap it, drop your answer in the comment section. You can also type it in the comment section. That's also good. And this is just the concept of prime numbers, and I believe we all understood everything I explained about the prime numbers. So the next we'll be looking at is the prime factorization. Now, talking about the prime factorization, you have to know this. Every whole number can be written as a product involving only prime factors. Every whole number can be written as a product involving only prime factors. Now, I'm using an example, 84, as an example. And I'm listing out the factors of 84. Now, the factors of 84 are 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, and 84. So these are lists of the factors of 84. 1 times 8, 2 times 42, 3 times 28, 4 times 21, 6 times 14, 7 times 12, vice versa it goes. Now, these are factors of 84 which we've learned, and you see that every whole number can be written as a product involving only prime factors. But in terms of this prime factorization, now we are picking only the factors that are what? Prime. Only the factors that are prime. So what is the prime factor of 84? The prime factor of 84 will be what? Prime factor of 84 will be the prime numbers that are factors of 84. And we start from what? We start from 2, we have 3, we have 7. And I think the prime factors of 84 are just 2, 3, and what? 7. Hope that is clear. That is the factors that are what? Prime. So hitting further, now in terms of the prime factorization, now let me show you how the prime factor can make up the value what? 84. Now let's use this simple division method. 84 are derived, and now look for a prime number that can divide 84 without any remainder. And we can go with 2. 2 is assured. It's out from the least value. So 2 divided by 84 gives us what? 42. This is good. So the least prime number that can still divide 42 is what? 2. 42 divided by 2 is what? 21. But at this point, we can see that 2 cannot go into 21. That's 21 divided by 2 will have a remainder. So we check for 3 and we see that yes, 3 is divisible. So we can use 3. 21 divided by 3 we have what? 7. So 2 is not divisible by 7, neither is 3 divisible by 7. And the next prime number we should use here should be what? 7. So 7 divided by 7 is what? 1. Now at this point, now the product of these values gives you what? 84. The product of these values, of these prime numbers, gives you what? 84, and that is what we call the prime factorization. So therefore we say 2 times 2 times 3 times 7 is equal to what? 2 times 3 is what? 4. 4 times 3 is what? 12. 12 times 7 is what? 84. This is a sweet and simple concept. under the prime factorization. We can see use another example. Let's go to 126. Let's use an example like 126. 126. And here, okay, 2 will be this prime number that can go for that. 126 divided by 2 will give us 63. 126 divided by 2 will give us 63. 63 divided by 2 will give us a value with a remainder. So we check the next list prime number, which is what? 3. So 63 divided by 3, and we'll be having here to be what? 21. 21, see? 63 all over 3. 3 here will give us 2, 3 here will give us what? 1. That's 21. Sorry, I wrote it here. 21, sorry. I'm supposed to write 3 here, not this. 21, still 21, 3 is divisible by 21, so we do again 3, and this will give us what? 7. And the next prime number will see you cannot use 5, you cannot use 3, you cannot use 2. You still go with 7 at the prime number, and here we'll have 1. Now let's see the product of these values. 2 times 3 times 3 times 7. So we say 2 times 3 times 3 times 7. So 2 times 3 is what? 2 times 3 is 6. 6 times 3 is 18. 18 times 7 is 126. This is a pretty simple concept. And understanding this foundational part of mathematics gives you an edge as you advance in the world of mathematics. So now let's dive into the HCF and the LCM. Now we'll be looking at the HCF and the LCM. A well-known topic for everybody. Just like rice and beans. Simple for everybody. Everybody knows this. But let's see this. Let's go deeper and let's learn more on HCF and the LCM. Now HCF, which is highest common factor, and LCM, which is the lowest common multiple. Now, the HCF of two whole numbers is the largest factor that they have in common. The HCF of two whole numbers is the largest factor that they have in common. Note that. Now, I'm giving an example. I say find the HCF of 84 and 512 and also the HCF of 63 and 42. So, solution. Following our method of prime factorization, so we'll have it to be what? 84. We can also have it to be what? Okay, let's take it one after the other. One after the other. One after the other. So 84. 2 divided into 2. We use 2 as prime factor for 84. To start the division, 84 into 2 will give us what? 40. This will give us 42. Am I right? 42 will give us 42. And here we have 2. 42 into 2 will give us what? 42 divided by 2 will give us what? 21. So we look for the next value. You know 21 cannot divide 2 without a remainder. There must be a remainder. So the next value, the next prime number we'll introduce is what? 3. 21 divided by 3 will give us 7. And here we have what? 7 divided by 7. We solved this earlier. So we won. So you can see that the prime factorization of 84 is what? 2 times 2 times 3 times 7 equal to 84. So now let's go for 512. 512. So the prime number, prime factor we can use first to begin the division is what? 2. 512 divided by 2 will give us in the 250. We have 250 there, and we have 256. 256. So 2 again can still go because it's an even number. 256 divided by 2. So we go, we say 100, 120, 120, 128. 128. So you go again 2. 128 divided by 2. 128 divided by 2 will give us what? This will be 60, 60. Sorry for that. 60, 60. That's 120. So that will be 64. 64. It's an even number. So 2c goes again. 64 divided by 2. 30, 30. That will be 32. 32 divided by 2. That will be 16. 16 divided by 2. That will be 8. 8 divided by 2 will be 4. 4 divided by 2 will be 2. And 2 divided by 2 will be 1. So the prime factorization of 512 is 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 raised to power 9. 2 raised to power 9, which is still equal to what? 2 times 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 2. 1, 2, 3, 4, 5, 6, 7, 8, and times 2. And this is equal to 512. So now, how do we pick the highest common factor between 84 and 512? What is the highest common factor between 84 and 512? Now, this takes us back to this definition of HCF. The HCF of two whole numbers is the largest factor that they have in common. The HCF of two whole numbers is the largest factor that they have in common. And here, we can see that the largest factor we have here, okay, here we have factors 2, 3, and 7. 2 is here, and 2 is here. So 2 and 2 is the highest common factor. That is 2 times 2. So therefore, HCF of 84 and 512 is equal to what? 2 times 2. That is what? HCF of two whole numbers is the largest factor that they have in common. So 2 is here, common here, and 2 is common here. So since 2 is common in both 84 and 512, so our HCF will be 2 multiplied 2. The HCF of 84 and 512 will be equal to what? 4. So that's the HCF of 84 and 512. You can also pause the video for about a minute and try for the HCF of 63 and 42. Hope you guys have gotten the solution. So watch out for my own solution of the HCF of 63 and 42. So I'll start 63, my prime factorization. So 2 is not divisible by 63 because if 63 divides 2, there will be a remainder. So we'll start with 3. So 63 divided 3 will have 21. Say 3 again. 21 divided 3 will have 7. So we'll go and 7. We have what? 1. So 63 and the prime factorization of 3 times 3 times 7. 3 times 3 is what? 9. 9 times 3 here. Sorry, 9 times 7 here is what? 63. So 42 is next. 42. The prime factorization. 42, an even number, so we can divide 2. So divide 2, we have 21. 21 do not divide 2, so we go with 3. And we have 7 here. 7 into itself here. We have here 1. So 42 here will be 2 times 3 times 7. Now back to the definition of the HCF. The HCF of two whole numbers is the largest factor that they have in common. And what is the largest factor that they have in common? 3 here is common, 3 here is common, 2 here, but 2 is not common here. So 7 here is common, and 7 here is common. So the HCF of 63 and 42 is what? 3 times 7, and that is equal to 21. So that is it. All I want you to do is solve further. Look for exercises and solve more of HCF. This is just a foundational aspect of mathematics. And I believe if we will learn this well, we will do better in time to come. Now we'll be talking about the LCM. Solving same examples under the LCM. Now the LCM is the smallest whole number that each one of a pair of whole number divides into a whole number of times. A bit confusing, but you have to understand it. The LCM is the smallest whole number that each one of a pair of whole number divides into a whole number of times. Now let's go to the example. And from the example, I guess you understand it better. So now we are asked to find the LCM of 84 and 512. Let's start with our prime factorization again. 84. So we are divided with 2. So this 84 divided by 2 will give us what? It's going to give us 42. 2 is going to give us 21. We did it earlier. 3, 7, 7, 1. So we know 84 is equal to 2 times 2 times 3 times 7. So let's go for 512. 512. We say 256. 2 here, and we say 128. 2 here. We say 64. 2 here. We say 32. 2 here. We say 60. 2 here. We say 8. 2 here. We say 4. 2 here. We say 2. And 2 here. We say 1. And you see that 512 is equal to 2 raised to the power what? 9. That is 2 times 2 times 2 times 2 times. Okay? 2 times itself 9 times. That is the prime factorization of 512. And now, how do we get the LCM? How do we get the LCM of 84 and 512? That's 512. So LCM is equal to. Now let's go back to the definition. The LCM is the smallest whole number that each one of a pair of whole number divides into a whole number of time. Lowest common multiple. Now let's check what is common between the LCM, between 84 and 512. Now 2 is very common between 84 and 512. 3 is not common and 7 is not common. But the definition, lowest common multiple, the smallest whole number that each one of a pair of whole number divides into a whole number of time. So this is what will be the LCM of 84 and 512. 2 raised to the power 9. That is 2 times 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 the smallest whole number that each one of a pair of whole number divides. So 3 multiplying it by 3 and multiplying it by 7. It does not matter whether they are common also here in 512 or they are not common. The concept of LCM is, now let's assume that in 84, let's say we are having 7 here to be 3, then times 7. So this will be, our LCM here will be what? 2 raised to the power 9 times 3 raised to the power 2 times 7. And even though 3 or 7 falls here, was still common. So that's just the pretty concept of LCM, and I want us to understand that. So now, sorry, this is off, and This is off. 7. So back to it. So now multiplying this 2 raised to the power 9 gives us what? 512. 512 times 3. And here we have 6, we have 3, and here we have 15. So 1536 times 7. Here will give us 42. Right, we carry 4, 21, plus 4, 25. Right, 5, we carry 2, 35, plus 2, 37. Right, 7, we carry 3. 7 times 1, 7, plus 3, give us what? 10. So the LCM of 84 and 512 will be equal to what? 10,752. So this is the LCM of 84 and 512. Now, let's try same for 63 and 42. Don't forget we did that earlier. Let's do same here. Okay, for 63 and 42 now, wash my solution and see if you got the LCM correct. So we start with 3, which we did earlier, and we'll be having here to be what? 21, 7, 7, 1, which we did earlier. So 63 is equal to 3 squared times 7, which is same as 3 times 3 times 7, and for 42, we'll be having 2 first. This into this will give us 21. 3 here we have 7, and 7 here we have 1. So 42 is equal to what? 42 is equal to 2 times 3 times 7. So now what is the LCM between 42, LCM of 42 and 63? The LCM of 42 and 63, but the LCM is the smallest whole number that each one of a pair of whole number divides into a whole number of times. Now, we are having 3 square. 3 is common here and common here. 7 is common here and common here. But at this point, we are having 3 square. That is 3 times 3. So let's pick 3 times 3. We are also having 2 and we are also having 7. Sorry, 3 is supposed to come before 3 times 3. So we see 2, we pick 2 as our first value times 3 times 3, because the highest index of 3 here is 2, that we are having 3 times 3 and times 7. The highest index of 7 here is what? 1. So multiplying this, 2 times 3 will be 6, 6 times this will be 18, 18 times 7 will be 1, 2, 6. Pretty simple. As simple as that when it comes to HCF and LCM. So thank you very much, guys. I believe in this video we've touched a lot when it comes to the fundamental aspect of mathematics. Started with factors, talked about prime numbers, talked about prime factors. We also talked about the HCF and the LCM, and every part of this lesson was broken down to the least way of understanding it. So I believe that we all have gotten something in one way or the other from this lesson. Please, if you have any challenge, feel free to drop your questions or your contributions in the comment section. And please don't fail to like, share. Please don't fail to like, share, and subscribe to this channel. We need you to subscribe. We need more audience. Please don't fail to like, share, and subscribe. And one more thing. Our MathTech private tutoring service is still ongoing. If you're a student, tell your parents, Mom, Dad, I want to enroll for the MathTech private tutoring service. We are here for you in any aspect you want. And if you're a parent, please don't fail to enroll your children in any aspect of mathematics, programming, academic coaching, or academic therapy, and also everything science. MathTech is here for you. Thank you. See you next time.